Hi class, I figured I'd hop on and go over quick check 1 for 3-2 where we are talking about double angle formulas. So the question says if sine theta equals 4/5, theta is in quadrant 1, we want to find the exact value of sine of 2 theta. So this is going to require us to use a double angle formula. So I come to my handy dandy cheat sheet here. And notice here that I have updated it to include your double angle formulas and half angle formulas for this section. I do also have the formulas that you'll be looking at in homework or in the section 3-7. So I need the first one here, sine of 2 theta equals 2 sine theta times cosine theta. So I'm just going to record that so I don't have to go back to it. Okay, now I am given that sine of theta equals 4/5. So I'm already partway there. So I can plug in sine theta for the right hand side over here, but I need to find cosine theta. So I'm going to use sine theta, the value that they give me for sine theta, to find cosine theta. So we know that sine theta is 4/5, which we also know that sine theta equals y/r. Okay, so if sine theta is y/r and cosine theta equals x/r, and we know that r squared equals x squared plus y squared, this is just like the Pythagorean theorem, just relabeled a little bit. Then we can just plug in y and r from sine and solve for x. So when I do that, I'm going to get that x equals the plus or minus the square root of r squared minus y squared. Okay, so now all I have to do is plug in r and y and simplify. So r squared is going to be 5 squared, and then minus y squared, which is 4 squared, which we get plus or minus 25 minus 16, which is plus or minus, just to simplify that a little bit, the square root of 9, which is plus or minus 3. Okay, y'all might have recognized this if you are an astute student here, that the 3, 4, 5 is one of our common Pythagorean right triangles. So you might have been able to not have to do this if it was one of those common Pythagorean triples there that you recognized. All right, but notice that something that I have tried to emphasize this semester, whenever you're solving a quadratic equation, you're going to be given that positive and negative result. So I have to pick which one. Is it the positive 3 or the negative 3? Well, that's where this quadrant 1 comes in. Theta being in quadrant 1 means that both x and y are going to be positive. So I'm going to only use the positive result. Okay? Not the negative. So we have then that x equals positive 3, which tells us that cosine of theta, is going to be 3/5. So cosine. All right, so now I am ready to use my double angle formula up here and plug the value for cosine theta and sine theta into the right hand side. So sine of 2 theta, whoop, my brain went ahead of me there. Sine of 2 theta equals 2 sine theta, but we said sine theta was 4/5, times cosine theta, but we said that cosine theta was 3/5. Okay? So now we can multiply those out real quick. 4 times 3 is 12, times 2 is 24. And then 5 times 5 is 25. I can't simplify that, so my answer is going to stay 24 over 25. And there you go. Have a great day, guys.